This is section 1.1 in Math 120. The first concepts we have are function values. Remember that y is equal to f of x, and we're looking for decreasing in domain and range. So if we look at graphs like this for f and g, they're given here. They want us to take the values of f and negative 4. Well, f of negative 4 means go to the x that equals negative 4 and find the y value. So we're looking at the f graph, which is the purple or pink one here. We want at negative 4, 1, 2, 3, 4, and it looks like the value for f at negative 4 is negative 2. If we look at g of 3, that's g of 3, looks like that value is 2, 3, 4, is 4. On the next question, it's saying for what values of x is f of x equal to g of x, which is basically where the two graphs intersect, where the y values are the same. So what values of x? So x is here at 1, negative 1, negative 2. So x equals negative 2 and x equals 1, 2, x equals 2. That's where these two graphs cross. At what interval is f decreasing? Well, f is decreasing, that's the purple graph here, or the dark pink, from 0 to 4. And when they say the intervals, is it decreasing, that means the y's are going down, so the interval, it would be the x interval. So if the y's are going down, what's happening to x? And I would put open intervals here, though some professors would put closed, open. State the domain and range of f. Well, the domain and range of f means the domain is the x and the range is y. They're in alphabetical order. Some trouble when I learned it the first time, remembering which was which. But also the line's domain is the plane, so that's horizontal, and the mountain range for the y. So that's, the range is like mountain ranges. All right, so this domain of f would be the x values, which is 1, 2, 3, 4, negative 4 to 4. And the range of f would be negative 2 to 4, to 3. 1, 2, 3, right? Negative 2 to 3. Again, I would put, I would actually put closed intervals on this one because this implies that it stops there and it doesn't have an open or close, so I'll assume that it actually wanted to include that value. Here we want to determine which of these graphs are functions. And remember that if you're looking at a graph and it fails a vertical line test, so you put a line down and it touches the graph more than one time anywhere, then the graph is not a function. So this one is not a function. This one is a function. This one also is a function. If these were both closed circles here, then this would not be a function, but I have an open circle and a closed, so it's defined here and not here. The last one here actually has vertical lines in it, so it fails the vertical line test. Now I remind you that you can pause the video at any time, so you could have gotten the answers to these or thought about the answers to these before I said anything conclusively about the question. You should be able to read graphs like the one here. This graph is of the height of the water in a bathtub as a function of time. So over the first few minutes, it took about 5 minutes to fill the bathtub up. And then it looks like somebody got into the bathtub, sat in the bathtub a while, got partially up, and then sat back down, and then got out of the bathtub and let the water drain. That's what it looks like to me. I'm going to work all the way through number 23 here, so you might want to take a moment and write down the problem and perhaps work through it before I do, or as I'm doing it. First, I want to show you some calculator keystrokes that will save you a fair amount of time if you're having to put numbers into equations like this, especially if you're going to have to do several of them. The first one I want to show you is if I first store 2 to x, so that was 2 stored to x, hit enter. Now I've put that basically in the mailbox that's called x on this calculator, and we have A through Z, so we actually have 26 mailboxes, places, little cubby holes that we can put numbers into our calculators and store them for later. Now if I just type in 3x squared minus x plus 2, 3x squared minus x plus 2, and hit enter, it will tell me what f of 2 is. So that's one way that I could have done this. I could also now do negative 2 stores to x, hit enter, and then I can scroll back up and grab my equation, hit enter again, and it tells me what the value would be if I put -2 into the equation. So what does this look like if I work it by hand? It means that I'll have to put 2 into the equation. 3, I get 2 squared, minus 2 plus 2, and that's going to give me 3 times 4 gives me 12. Minus 2 plus 2 is going to give me 0. If I put -2 in, I have 3 times -2 squared minus a -2 plus 2, which will give me 3 times -2 squared is 4, that's 12, plus 2 is plus 4, which is 16. And those are the same answers I got before. Now the rest of these I have to do by hand because there are no numbers that are given in the problem. So f of a means everywhere I've got an x, I'm going to put an a. 3a squared minus a plus 2. F of -a means everywhere I've got an x, I'm going to put a -a. Well, -a squared is going to give me a positive, so this will be 3a squared. A times negative will give me a positive a plus 2. So it's really very easy. Now, putting a plus 1 in here, I got 3 times a plus 1 squared plus a plus 1. I'm sorry, that should be minus. So minus x minus a plus 1 plus 2. So if I FOIL this out, I'll get 3 times a squared plus 2a plus 1 using formulas minus a minus 1 plus 2, which gives me 3a squared plus 6a plus 3 minus a minus 1, and I can see that gives me 3a squared plus 5a plus 2. 2f of a means I'm just going to multiply this by 2, so I'll get 6a squared minus 2a plus 4. These are very straightforward, very simple, so don't try to overwork them. Putting 2a in, everywhere I got an x, I'm going to put 2a. So I'm going to write out all the steps I'd put in. I might skip some of these on my own, but it just means put 2a everywhere you see an x. So I'd have 2 squared is 4 times 3 is 12, a squared minus 2a plus 2, and I'm done. Putting a squared in, I'll have 3 times a squared squared minus a squared plus 2. Everywhere I had an x here, I'm putting a squared. So I end up with 3a to the 4th minus a squared plus 2. And that's actually called a quadratic form. This says f of a squared, so that actually means 3a squared minus a plus 2 squared. So I'd have to FOIL this out, and I don't expect you to do that level of arithmetic on this first test. F of a plus h means everywhere I see an x, I'm going to put an a plus h. 3 times a plus h squared minus a plus h plus 2. So I have 3 times a squared plus 2ah plus h squared. And I'm using this formula, a plus h squared is equal to a squared plus 2ah plus h squared. It's actually a formula. Minus a minus h plus 2. So if I multiply through the 3, I get 3a squared plus 6ah plus 3h squared minus a minus h plus 2. And there's nothing I can simplify there. I'm going to go back to the calculator for just a second to show you another trick that you can use to find function values here. There's actually several different ways to do it. I'm going to clear out whatever I have in here. I went to y equals. I'm going to put in my formula 3x squared minus x plus 2. 3x squared minus x plus 2. Now I could have put this in here to begin with, and it would have made my life a lot simpler. I'll do second quit and get out of here because I want that stored. Now I'll do a second table set. And I can start my table at 2 because I'm only, well, -2 because I'm only interested in -2 and 2. So if I start my table at -2, and remember that a negative and a minus are different, and then have the delta table be 1, and I could have it be 4 so that all I got was -2 and then 4, but delta tables 1 is fine. If I look at my table here, I see that -2 is 16 and 2 is 12. You could have just as easily done it by hand. There are several ways to do things on a calculator. The store is my favorite one because oftentimes I only want one particular value for any particular equation. Oftentimes we see piecewise functions in mathematics because for a while you're doing one thing and then you stop and then you do something else. That's what that actually represents. I'm going to look at number 45 here, and I'm going to go to my calculator to do it. I'm going to first show you that second test here has the inequality symbols that we're going to need. There's also logic symbols here, so if I needed an and or an or a not, an and would be what I would need if I had a double-sided inequality, like -3 is less than x is less than 2. But I don't need it for this problem. So just letting you know, that was second test, and it takes you to these symbols so that you can put them in your equation. So when you have this kind of problem on the test, and I did say when, you'll have a piecewise function that's written like this, and in your calculator, I'll ask you what would you put in your calculator, and this is how you would put it in your calculator. Around each of the pieces, you're going to put parentheses, and right up against it, you're going to put the restricted domain. So this would have parentheses around it. And you also want the second piece, and that's like a fifth grader going, and I did this, and I did this, and I did this. Well, that's what I'm doing. I'm doing an and there, which is a plus. It's not the word and. Parentheses around the piece, parentheses around the domain restriction. So let's go back to the calculator and actually put this in. So we have the pieces exactly like I have here. Everything's with parentheses, so the parentheses are here on your calculator. And remember that second test is where you're going to find the less than or equal to or the greater than that I need here. So I have this function written beautifully. I'm going to use the zoom features. Zoom 6 takes me to a standard grid, gives me 10 by 10. Well, actually it's 20 by 20 in both directions, but it's not square. So I'm going to zoom it square once it stops. Zoom square is zoom 5. And then once that stops, I want to zoom it in because I'd like to look at the middle of it a little more closely. You can always go back to zoom 6, zoom 5, and then zoom in anywhere you are in your graph. Now in my graph I can trace, so I can actually have it scroll across and see where I am at particular points on the graph, but that's not very accurate. So if I do a second calc value, I can see what the values are. For a -1, it looks like they're both the same value. -1 plus 2 is going to give me 1, and -1 squared is going to give me 1. So if I put -1 in here, notice which piece it's on. So this one is actually on the first piece of this function, the less than or equal to. So it's on the line that's going up, the x plus 2, positive slope. And the second piece comes right up against it. It's kind of like putting little Lego train cars together. So to complete this problem on the test, you would sketch a graph real quickly. And all I want is kind of a sketch. I can see that that's at 1. So I might put these values in. I don't need very much here. I don't need arrows. I don't need a whole bunch of tick marks. But I can see the interesting thing that's happening here is there at the 1 that looks like this is a parabola, which is what it is. And enough is good enough. So this would give you full points if you turn in a graph like this with the understanding that this is what you put in your calculator, which is what I will ask you for. We're now going to go over to the WebAssign 1.1 assignment and look at a few things that you should consider when you're going through the assignments. You'll have some problems that look like this that have video examples, so you turn on the examples and you go through it. It also has a link to the online textbook. If you purchase that, then it'll go directly to it. If you don't purchase the textbook, then you won't be able to go to the textbook links. But the video example will be available to you. This kind of problem here is kind of tedious because you're having to slow down your thinking from what you usually do and put in little bitty pieces. I don't give you very many of these all semester long, but I did want you to get the feel for slowing down your process and actually looking at what this is asking you. You have a while to do this assignment, so please take your time and do it carefully. On the next one here, they're trying to determine whether there are even, odd, or neither functions. And here, the video examples will explain to you what even, odd, or neither are. But what I need you to be able to do for the test is determine these by the powers of the exponents. So if the powers of the exponents are all odd, and you can see here this is x to the 7th, that's odd, x to the 1st, that's odd, this would be an odd function. Now they're going to have you go through the solution here like they do in the video example. So I won't expect the video example way on the test. You can just take a look at this and see this is an odd function. With the same idea on the next one, this is 1x to the 0 because there's no x here, there's 0 x's. So this is a 0 power and this is a 6 power. So this would be an even function. The next one has an odd and an even, so that would be a neither. So when we look at this, it's going to show you down through, all the way through this, asking you to be able to do these by putting values into the function. So take a good look at the video examples and you can work through that pretty quickly. I will not ask you to go through these on the test, but you are having to do them here, so you are kind of being quizzed on them because you're having to do them for homework. The homework you can turn in several times. I think I give you 5 tries on each example. So just keep trying if you're having trouble with it. This one we've looked at already. Going to number 7, I can see that I've got a function here, we got 3x squared plus x plus 4. I can actually copy this function, Control-C, Control-V, and put some things in here. So this is to the exponent, so I put to the 2nd power minus x plus 2, so that'd be putting 2 in here. Notice that it doesn't say to solve it. And you can solve and see if that actually works. And once I have the equation there, and usually you'll have this pop up where I can put a formula in, see, like this, and pop up so I can put formulas in, but I'm actually putting a value in here. So I should just put a value in here. So it's probably not going to let you do this one. But if I bring this down here and replace these with a, then this should work beautifully. Sometimes a negative doesn't work right. You might have to retype that. But this would be the answer. It's not saying to simplify, so you don't have to simplify. Even down here for f of a plus h, I showed you simplified on the page, but when you're working through this example, you really could just copy this, Control-C, paste this, Control-V, and put a plus h in here. And you'd be done with the problem. There's one submit button for all of these, so if you don't put answers in, it gives you 5 tries on each of the answers. So you can take your time doing them. Notice on number 8, it does say simplify your answer. So you would have to put this in, the a plus h in, cube it, subtract f of a, simplify it, divide by h, and they would want your answer in here. So it does say simplify, so be aware of that. If you need me to, I can put more of these examples online. Here they're asking for the domain of the function. Sometimes the easiest thing to do here is to graph this on your calculator. I could work these pretty easily. For this first test, I would expect you to be able to do them by graphing them on your calculator. For this next problem, graphing on your calculator, being able to do the domain of the function, here there's a little pop down that's asking you for open or closed intervals. So remember at infinity, you have an open interval. I think when this becomes 0 at 13, you'll have a closed interval. So just be aware that there are little pop down menus here for open and closed intervals. You can determine even and odd on a graph, I'm down at number 16, by folding. If you fold along the y-axis and the graph lies on top of itself like G does here, that means that it's an even function. If you fold along the y and then fold it on the x and it lies on top of itself, that means it's odd. Another way you can tell it is that it's even if every time you have an x on this side, negative x is going to give you the same y value. It's odd if every time you have an x on this side, negative x is going to give you the negative of that y value. That should be enough to get you through section 1.1 homework. So please see me on office hours if you have questions, or send me an email with a screenshot being very specific about the question that you have, or contact me in Canvas.